In this tutorial, we are simply going to be looking at some basic problems that has to do with writing the electron configuration of some basic element or an atoms. Let's assume you're given this kind of problem where you're given iron, ferrous iron, copper and cobalt, and you are asked to write the electronic configuration of this. How can we solve this problem? Notice that what we have first, or the last one, let's start with the last one, which is CO. This CO is not actually carbon and oxygen. Rather, this is what we call the cobalt. What about the next one? The next one initially is supposed to be Cu, and Cu is copper. But since we have positive here, it's going to be copper ion. Before this, let's try this. This is what we call the ion. But in a situation where you're having Fe2 positive, this is simply going to be ion 2, or you can call it ferrous ion. Notice that on our periodic table, let's take an example of the first one. We have Fe, and we have there is something we have on the superscript and the subscript. When we say superscript, which is the up part, subscript Sb, which is the down part. In the case of iron on our periodic table, what we have on the superscript, we have 26. And the subscript, we have 55.86. In this case, this is simply going to be our atomic number, and this is going to be our atomic mass. Notice that in order for you to find electronic configuration of any element, you are simply going to be using this, which is the atomic number. Let's take an example with the second one. Let's say on our periodic table, copper. What we have on the top is 29, which is the atomic number. And the subscript, what we have for the copper, we have 63.546. This is atomic number, and this is atomic mass. What about cobalt? On our periodic table, the cobalt, which is CO, what we have in the superscript for the cobalt is 27, and the subscript is 58.93. In this case, this is going to be our atomic number, and this is going to be our atomic mass. Okay, let's dive in together and see how we can solve this problem. Starting with the first one. Since we said iron, which is Fe, our atomic mass is 26. Atomic number is 26, atomic mass is 55.86, and we are asked to find the electronic configuration of this. Notice that iron has electronic configuration of 1s2, 2s2, 2p6, 3p6, 4s2, and 3d6. For you to have a better understanding of how I'm writing this, I have a video which I'm going to drop the link down below in the description. I have a video with a title notation system for writing the electronic configuration. That video I'm sure is going to enlighten you more before you can solve this problem. So let's continue. Notice that here we have 6. Let's try with the capital number 6 and 6. No, let's write this again. The electronic configuration we said is going to be, for iron, it's going to be 1s2, let's confirm, 2s2, 2p6, this is going to be 3s2, then 3p6 before 4s2, then the last one is 3d6, and this is the correct one, not this. So let's confirm, is what we have here in the superscript, is it the same thing with the numbers of our atomic number? If it is the same, then our electronic configuration is correct. Notice that the big number which we have here is 6 and 6. 6 plus 6 is simply going to be 12. Here we have 2, 4, 6, 8. 3d is going to be 6, right? 2, 4, 6, 8 is going to be plus 8. Plus 6. 12 plus 8 is simply going to be 20. 20 plus 6 is simply going to be 26. And the numbers, and our atomic number here atomic number is 26. Therefore, this is it for this problem. When it comes to iron, the electronic configuration is simply going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. And this is it for this problem. Let's try another problem. Let's say the next one. So the next thing we have on the list is, ferrous iron. Ferrous iron, which is Fe2 positive. When iron loses 2 electrons, it forms this. This is what happened to it. It's nothing, but the iron actually loses 2 electrons. And in this case, the electrons it loses is simply going to be 4s2. That is the first electrons, right? So resulting in the electron configuration of this is simply going to be 1s2, 2s2, 2p6, 3s2, 3p6, and 3d6. If you plus 6 plus 6 is simply going to be 12. 2, 4, 6 plus 6 plus 6. This is simply going to be 12. 12 plus 12 is simply going to be 24. Initially, iron have 26 numbers of atomic mass, but Fe2 positive is simply going to be 24. And this is it for this problem. Our answer is correct. What about the next one? The next one we have is copper iron. We said copper iron is being donated by 2 positive. So in this case, when copper forms 2 positive ion by losing 1 electrons, its configuration is simply going to be 1s2, 2s2, 2p6, 3s2, 3p6, and 3d10. And remember we said the copper Cu, right? The atomic number which you have initially, atomic number is 29. What about the atomic mass? Atomic numbers of copper, remember we said is 63.546. Okay, let's try to do it this way. If you say 10 plus 6 is simply going to be 16. 2, 4, 6 plus 6 is going to be 6 plus 6, which is going to be 12. Next thing you need to do is to plus your 6 plus 12. Right? 6 plus 12 is simply going to be 8, which is 8. Here is going to be 28. Remember, instead of 29, it loses 1 electrons, which will result in 28. Therefore, our electronic configuration is perfectly correct. What about the next one? Next thing we have on the list. Have we done for ferrous? Yeah, we've done that. Oh, the last one, which is cobalt, which is CO. In this case, notice that our cobalt, we have the atomic number. And the atomic number of cobalt is given to be 27. And the atomic mass of cobalt is simply 58.93. In this case, cobalt has an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d7. Okay, this is 2. Since it's s, this is going to be 2, 4, 6, 2, 4, 6, 8. Therefore, all s is 8. We are going to be left with pp. P is simply going to be 6 plus 6. And the last one, which is simply going to be 7. 6 plus 6 is simply going to be 12. If you plus 12 plus 8 plus 7, which is simply going to be 27, because 12 plus 8 is simply going to be 20 plus 7, which is simply going to be 27. And this is it for this problem. Our electronic configuration for cobalt is perfectly correct. So, as I mentioned earlier, I also have a video on notation system for writing the electronic configuration. Feel free to check that one out, which I'm sure is going to help you to solve this problem. Thank you for watching, and see you next time.